All right, welcome back, everybody. Today we're talking about stem and leaf plots. Sounds exciting, doesn't it? I know. Can't wait. Um, Stem and leaf plots are a way of organizing your data. Just like and the first thing that probably comes to mind when you say organize your data, you think, oh, make a table, put it in a table, label it, do something that's going to make it easier to look at and easier to use than just a whole bunch of random numbers on a list. So that's what we're going to do on our stem and leaf plot. So if you look on your handout, this is an example of what a stem and leaf plot looks like. It is a two-column chart, basically. The stems are on the left, the leaves are on the right. Your leaves are always, always, always a single digit number. So this side is going to be a single digit number. Now the other side doesn't have to be. It really just depends on your data. But most of the time, it's a matter of just place value. So the way you figure out what those numbers mean is the key. There has to be a key. Just like on a map, you have to have a key to tell you what all these little symbols stand for. On your stem and leaf plot, you have to have a key to tell you what these numbers mean. So if I have a 2 on the left, and then I have this vertical bar, this line, and then a 1 on the right, that stands for 21. So if I apply that to all of these pieces of information up here, if 2, a bar, and 1 means 21, then the 2, which is my stem, must equal the tens place. And then my 1, which is the leaves, must equal the ones place in this case. It's really just a matter of what is the place value of each of your stems and what's the place value of your leaves. So on my stems, a 0, the vertical bar, and then an 8 stands for 0 tens and 8 ones, which is a total of 8. Another 0, vertical line, and 8 means I have another piece of data that is also 8. 0 bar 9 means, what do you think? It means I have 9. I have 0 tens and 9 ones. Then if I go to the next line, this is going to be it says I have 1 10, and then the bar separates from the ones. The 4 on the leave side means I have 4 ones. 10 or 1 10 and 4 ones makes a total of 14. 1 10 and 5 ones is 15. And 1 10 and 7 ones is 17, and so on. 2 tens and 1 1 means 21. That's where our key came from. 2 tens and a 6 ones means 26, and so on. So if you look at your 30s, we have 3 tens and then there's nothing. There's no data over here, which means there's no data in the 30s. And then if I have 4 tens and 0 ones, that would be 40, 42, 43. So you can hopefully start to see the pattern. So based on this, we're going to use this organized list of data. Instead of this list like this, we're going to use this to help us answer those questions. So a lot of these you could really probably do without my assistance, but let's go through them quickly on our own. It says, what is the range of washed cars? So if you remember, the range is highest minus lowest. So what is our highest value? And it should be at the bottom because these are in numerical order and they get bigger as you go down. 40, and then our furthest stem to the right is our highest number. So 43, and our lowest number was the very first one here, 0 tens and 8 ones, which is 8. So our range in this case is 35. So that means there's a gap of 35 between our highest number of cars and the lowest number of cars at our car wash. Okay, what is the mode? Remember, mode means most frequent or most often. So which number or numbers are listed the most? Well, we have 2 eights, and then if you skim through here, looks like that's all we have. So the mode is 8 cars washed per hour. The median. Now, remember, your median is the middle number. So let's go back up here and look. Um, Before I said you have to put your numbers in order from least to greatest. Well, if you look at your table, they really are already in order. We're starting off the lowest numbers here, and then as we go down and further to the right, those are our biggest numbers. So you can really kind of count it off by the stems, the leaves. So if I match up, let's see, 8 and 3, and then I'd go 8 and 2, 9 and the 0. Those are all partnered up. And then I go to the next line. The next smallest number is 14, and then the next biggest number would be 28, 15, 27, 26, and 17. So this one right here is the middle number all by itself. So that is two tens and then a bar and 1. So the median is actually 21 in this case. Okay, so number 4, it says, what if the car wash was extremely busy for a few hours in the afternoon and they washed 56 cars, 73, 94, and 106 cars in 4 different hours of time? Add these pieces of data into the stem and leaf plot above. So let's take these 4 data values and let's add them into the stem and leaf plot that's already here. So you might need to extend your line a little bit. So why don't you see if you can add those 4 numbers in here on your own. Pause for just a second, and then come back in just a minute here and check it once you get it done. Okay, so we needed to add 56. That means 5 tens and 6 ones. We could go up to the 6s. Did we need to add any 60s? Nope, so we'll leave that blank. 7s, we had 73. 8s, we didn't have anything, so we'll leave that blank. 9s, we 94, and then the last 106 is going to be 10 tens and then 6 ones. So you'll have a 10 on the left and then a 6 on the right. Okay, so now that we got that one, let's go on to the next page. We've got a basic idea here, so let's see if you can put this into action. So feel free to look back at your last example to help you out. I've got this started set up for you. It says the data below shows the number of years coached by the top 15 coaches in the all-time NFL coaching victories. Make a stem and leaf plot of the data. So here's the number of years. So somebody coached 33 years, 40 years, 29 years, and so on. So you need to figure out how you're going to break this up into your stem and your leaves. And don't forget, you need to put a key at the bottom. So why don't you take a minute on your own, or a couple of minutes, and try that out. And go ahead and get your data included there. Set up that stem and leaf plot, and then check back in a minute to check yourself. Pause now. All right, well, how did you do? Now your stem and leaf plot really should look exactly like mine. You should have your 1, 2, 3, and 4 for your stems. Your leaves you should have on the first row 2, 5, 5, 7, 7, 8. Make sure you put those in order. The reason why is because if you are looking for the median, everything's in order. So don't just put sporadic random numbers and just make sure you get them all in there. You want to add them, make sure they're all in correctly in the correct order. And then so on. I'll let you just compare that. And then make sure you have a key. Now your key doesn't have to be the same value I chose, but it does need to be something that's actually on the stem and leaf plot. Otherwise, it seems pretty silly to put a key of using a number that doesn't even exist up here. So I chose 40. So 4 and then the bar and 0 means 40. So as long as you chose something up here, your key can be different. All right, so hopefully you have the basic idea down. Now we're going to add one more piece of information here, and we're going to go to what's called a back-to-back stem and leaf plot. And the difference between a normal stem and leaf plot and a back-to-back stem and leaf plot is that the back-to-back will contain 2 different sets of data. So if you look at this one, it shows the number of wins on one side and the number of losses on the other side by the National League during the 2006 baseball season. So on the left over here are my leaves. These are leaves for the wins. And then over here are the leaves for the losses. So then obviously what's in the middle are going to be my stems. Now, this you definitely need a key because you have to understand how to read each side. So if I have an 8 with the bars around both sides, that means this 8, see, the bar is here and the bar is here, and a 6 to the right of it, which would be this one or this one, that means 86. So that's telling us that a team got 86 losses in one season, that 2006 season. If I were to apply that to everything on this half, if I just kind of ignore all this over here, 6 in the stems column and a 5 on the right means 65, 74, 74, 77, 78, 80, 82, 83, 84, 85, 91, 96, 95, 96, so on. So those are all your losses. Then if I have a bar around the number and then another digit to the left, that you kind of read it, you basically read it backwards. That means 97, 9 tens, 7 ones. Remember, these are all stems, so in this case, these are the tens place. 6 tens and 6 ones means 66. 6 tens and 7 ones, 67, 71, 75, 76, so on. Here's your 79. So all of these, it's kind of like a mirrored reflection of the losses side, but it's going to include your wins. So you share the stems and then you put in your own leaves based on the information given. So that's what a back-to-back stem and leaf plot looks like. So let's see if we can answer a couple of these questions based on that table. It says, what is the range of wins for the National League last season? So that means we need to go to the side that has the wins and find the highest number and the lowest number. So let's look at the win side. First of all, what's our highest number? That would be 97. What's our lowest number? That's going to be 66. So our range is a total of 31. So we did 97 minus 66 equals 31. Now, what's the range of the losses for the National League? We'll go back and look at that one. Losses, highest. How much is the highest? 96. And what's the lowest on the losses side? And you should have had 65. So then when you subtract, you get 31. So even though the numbers are different, your range is actually the same. So this was 90. I've already lost it. It was 90 what? 96 minus 65. And that was 31. Okay, now how many teams make up the National League? Well, look at what you're given. Remember, every team has a winning record and a losing record. So the two together go with one team. So whoever got 65 losses probably had the 97 wins to make up their total number of games. So the only thing we need to count for the total number of teams are the leaves on one side. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So we're talking about 16 teams here. Okay, and then this is the big one. What is the average or the mean number of wins for the National League? So you want to go back, we want to find the average. So I'm going to let you do that one on your own. We want to know the average number of wins for the National League. So we want to focus on this side over here. So think back to how you find the average. You're probably going to need that old calculator. And then pause the video right now and then come back to me in just a minute once you've got your answer. Make sure you write down the sum that you get when you add up all your data values. All right, well, hopefully you looked on this side and added up all your data values. And once you do that, you should get a total of 1,267. If you remember, we already established in number 8 that there were 16 teams. That means there's 16 different sets of wins. Divide that out with your old calculator, and you get about 79.2. You can't have 79.2 wins, so we'll say approximately 79 wins was the average. And there you go. That is it. So that right there explains the stem and leaf plot. So you've seen how to read one, you've seen how to make one, and then you've also seen how to read a back-to-back stem and leaf plot. So the next, you need to go back to your Moodle page, and you should click on the stem and leaf plot assignment. And when that opens up, that'll be your practice on this particular part. You will be making a stem and leaf plot, and you will be making a back-to-back stem and leaf plot. So you're going to have to take what you just learned and see if you can't apply that and actually create your own stem and leaf plot based on that data. So make sure you look at the key, and good luck. Let me know if you have any questions. Make sure you give a key on all your stem and leaf plots too. All right, see ya. Wouldn't want to be ya. Just kidding.